Okay guys, here we go. So let's look at problem number 7C. Again, we have a concave mirror. The object distance from the lens is 5, the focus is 7, and the height of that object is 2. So the first thing I need to do is I need to build my ray diagram. So I'm going to start out with a horizontal line. And then we're going to pick a vertical point. I then need to put in my measurements. So P is about 5. Okay, so that's P. I want to go, oh, I didn't make my line long enough. It's a normal problem. You just extend it out. So 2 centimeters away from that, right about here, is going to be my F. And I also need to put in C. And so C is always 2F, so C is going to be 14. And so just do it 7 away from that. So C is all the way over there. Cool. I then need to do my height of my object at P to be 2. Okay. So not bad. I now have my rays diagram. Now the rays are drawn the same way for both lens and mirrors, except for ray 3. So the first two, we just follow the same rules. First one we draw in is horizontal. Or perpendicular to the lens. It then is going to bend and bounce back. And go through F. That's my first ray. Okay, my second ray is going to start at the object and go through. Wait a minute, the object, that would go this way, I would never hit the lens. So it's real simple. Just switch these. I care about the fact that this object has light bouncing off it in every single direction. I care about the beam that's coming up this way. And I care about that in the direction of the focus. And so, although I don't care about the bit from, say, here to here, you could still draw it. It's not going to hurt you. I care about this line here as it then comes up and hits the lens, which, look, I didn't make my lens big enough. The assumption is these lenses, or mirrors in this case, are infinite. They keep going up. You can't miss them. Yes, in the real world we can miss them, but that's the next level. We're not there. And once it hits here, it's going to bounce and then go horizontal. So let's draw this going horizontal. Now I can look, this line's going away, that one's going straight. These will never cross on this side. If that's the case, I now want to take it and draw the imaginary line, or the virtual line, and that's going to go into my mirror, and it's going to go in according to the reflected light ray. So this came in, it hit, it has angle as incident. The one that reflects out, that is the angle at which I draw. And let's extend this out a bit. Now a dashed line means it's not the real light beam, it's the virtual one. So then I need to go back and finish my ray 1. I need to draw that according to its again. On your paper, the advantage is most of these aren't drawn to this extreme. So that's they cross, so that's fine. And then my third ray, okay, starts from C, goes through P and go, well, it's shooting at the right direction, so let's draw it. It's about right there. The secret to continuing the line is you leave a little bit of the overlap. Not bad. It looks like the triple point's going to be right here. So here is my new object. And so I can extend this out if I want to make it all pretty. And there, that's my ray diagram. So let's look at through some of our answers. The questions we're looking at, is it real or virtual? Is it inverted or erect? what's Q and what's the height of my image. Okay? So if I look at that, I can measure it out. If I measure it out, on the scale that I had, this is in between 17 and 18. So a little bit past the halfway point, probably about 17.6. Now we're going to actually go through a way to verify this to see if everything's on the up and up. The height of the object, we'll come back to it. Let's prove this right now. The Lenz law equation, which says 1 over the object distance, okay, remember this is our P, plus 1 over Q, well, this is Q, that is the image distance from the lens, equals 1 over F. Okay, so in this case P was 5 centimeters. I'm trying to prove what Q is, so I'm going to leave Q as the unknown variable, and F was 7. Now we have a choice. What is the value of F, if it's a negative or positive? And a good rule of thumb to go with it is wherever the light really is, if that's the focus you used, that is the positive focus. So in this case, the real light bounces back. The blue line's a good way to look at it, and goes through the focus. That means this focus, if I were to use this one, it's positive. Well, that's the one we use this time, so this would be a positive value. So 1 over Q equals 1 over 7 minus 1 over 5. And then we can just plug that into the calculator. 1 over 7 minus 1 over 5. That gives me, right now, 1 over Q equals negative 0.05, 7, 1, and so on. So 1 divided by that answer, so Q is equal to negative 17.5 centimeters. Now that's pretty good for measurement to that. Okay, this number matches. I'm in good shape. I could take it another step further. The M is equal to negative Q over P, magnification. So in this case, that would be negative 17.5 all over UP, which was 5. So the M is 3.5. Now it's positive, which means it's erect. Positive means it's moving up in the positive direction, while this one was moving positive, and my original object here was moving positive. So it's erect. It's using virtual lines, so it is virtual, which I could also figure out from the negative Q. Now, what is the height of the object? Well, 3 times the height of my object will give me my height of my image. So 3.5 times the height of my object, which was 2, the height of the object should be 7 centimeters. By the way, both of these are centimeters. And if I look at that, yeah, 7 centimeters. Actually, it's pretty close right on. The graph paper would make that really, so these numbers should match. And if you were being thorough and really wanting to get this right, I would do the diagram first. I would then do the math to verify what's there. Now there are times where the negative side of the focus might throw you off, but that just means you should reevaluate and check it. Okay, but here's the answer to C.